in this next session, we will explore how places like California and the UK are leading the way with innovative regulations and how top thinkers are teaming up with lawmakers to keep climate progress on track, even in the face of denial and doubt. And for this panel session, it is my pleasure to welcome Baroness Bryony Worthington as our moderator, and Professor Fuad Kozmoud and Dan Travers. Please, a round of applause. Thank you.
Well, hello, and welcome to our panel. We are going to be delving into the topic of AI, artificial intelligence, and we're going to be looking at examples of how AI is being deployed for good in helping speed along our response to climate change. And I'm delighted to be joined today by two practitioners of the art of artificial intelligence who are going to bring a variety of perspective, both from the types of applications they're working on, but also the geographies that they work in. So first of all, Professor Fuad Kozmoud, who is a professor of computer engineering at Cal Poly in California and a visiting scholar here at Imperial for the next couple of months, and Dan Travers, who is the CEO and founder of Open Climate Fix.
Thank you, Dan.
So I am going to interview our panel. We will have a little session at the end where we can possibly take a few questions, so please feel free to be thinking about questions you might want to ask on this topic. I'm going to start with you, Fuad, if I may.
Please.
So tell us a little bit about what you do in this space of taking these AI tools and applying them for good.
Thank you, Baroness Bryony. So what we do is we have partnered with a nonprofit news agency in California, which is a very rare thing because news business is terrible and it's been devastating. But a nonprofit news agency called Cal Matters has been doing wonderful work, and they're succeeding. And what they're trying to do is to bring the proceedings of the California State Legislature to the people and to journalists who can't be there because of cost reasons and other reasons to witness what's happening in the Capitol for themselves. And these journalists from around the state are now able to use AI tools to cover the Capitol as if they were there physically, and AI is giving them tips about interesting newsworthy events that have happened in the Capitol that otherwise they would not know anything about, so that they could write their stories. So,
thank you so much, Fuad. And then at the other end of the spectrum, we're talking about energy transition and energy. Dan, do you want to say a little bit about what you do with Open Climate Fix?
Yes, thanks, Bryony. So at Open Climate Fix, we're focused on building operational AI tools to help the electricity grid run with a high amount of renewable penetration. Why is this important? Well, as you can see on Monday this week, with the blackouts in Spain, having a grid which is unreliable is a personal disaster for many people involved. It's incredibly disruptive for the economy, and it is a public relations disaster. Changing the electricity grid to run from hundreds of generators, as we had previously, even tens of large generators, to literally millions of generators on people's rooftops and solar farms and wind farms, as well as home batteries, as well as EVs, as well as heat pumps. So we're putting up to 2 to 3 times more energy is going through the electricity grid, and it's new types of electricity. How do you manage that? I thought of an analogy just on the way here, actually, as I was using Citymapper to get my way here. West London's a bit unfamiliar to me. I come from North London. How would I, in the old days, I used to actually look up the tube map and I would plot my route and I would try to estimate what the best route was. I now look at Citymapper and it just tells me 52 minutes, 53 minutes, 61 minutes. So I take the quickest one. That is AI optimizing my personal decision making and how I move around London's travel network. Imagine now that you are controlling the electricity grid. We previously have, and we currently do have, about maybe half a dozen people sitting in a control room just west of London who actually will tell power generators when to turn on and off in response to changing events. You imagine you're moving from tens of generators to a world where you have got millions of generators. That is infeasible. So basically, we need an AI tool that's going to help them send the electrons around the grid in a more advanced and easier way without having disasters. And that's what the tools that we're building.
Fantastic. And so the common theme here is an overwhelming amount of information, right? That there's just so much data or just information flow that if you want to make sense of that and then prioritize your actions, these are the sorts of things that AI are now very good at. So Fouad, tell us a little bit about how you go about this process of ingesting what is essentially a parliamentary discussion and then making that available to a journalist.
Absolutely. So we begin by ingesting videos that are available for legislative discussions in California. We're moving to other states as well. And we take the videos, we transcribe them, and then we up-level the transcription. That is to say, somebody actually double-checks all the words, because even now in the year 2025, with the best AI, we still don't have 100% accurate transcription. And for things like journalism and law, you have to have that. So we actually expend the cost to do that. Then we ingest maybe about 20 to 30 other sources, streams of information. These are databases, websites, government reports, and then sort of bring them all into the same database. And that database is available to be navigated and alerted and looked at by ordinary citizens. And then a separate AI process kind of crunches that information and comes up with tips for possible news stories. So essentially that in a nutshell.
Great. And I should perhaps use this opportunity to say how we met, because as I mentioned this morning, my heart is here in the UK, but I'm currently living in California, and I am involved in a project doing something very similar with the European Parliament and the UK. So ingesting all of that discourse, all of those videos, transcribing them, and then bringing out a feed of insights. And you can do some clever things, right? You can ask to look for the degree of polarization, like is the debate on topic X getting more polarized, or is it tending towards the center? And so if you care about democracy, which I hope we all do, and it needs preserving and protecting, and we've got to be vigilant, having these tools that can give you a kind of dashboard of what should I be worried about, what's happening in the world, is one of the brilliant aspects of this ability to take an information flow and take the signal out of the noise. So that's how we met, and that's why I'm delighted that you're here. But Dan, I wanted to get you to talk a little bit more about the specifics of your solar forecasting, because that's a different type of complexity.
Absolutely. If I can say one thing about Fouad's work is, I remember speaking to a lobbyist from Brussels, as you reminded me of Brussels, and her comment was, it was to a renewables conference, and her comment was the renewable energy industry and the people that use the energy are not represented anything like the oil and gas lobby in Brussels. So I think that work is really important.
Absolutely the case in California as well. And lobbyists, they have all the access already, so the people left out, they're the ones who need the tools.
Yeah, fantastic.
But Dan, yes, so exactly. So we've lowered the barrier to entry because now we're using computers where it would have involved a whole phalanx of probably young, not very well paid interns tracking everything and feeding it back. Now you've got digital, not interns, enthusiastic, not always right, but if you guide them in the right direction, you can get a lot done. But let's go into that solar forecasting, because this is super interesting.
Yes, so the first project which Open Climate Fix engaged in was solar forecasting for National Grid. So we worked with National Grid as a partner, and for us partnering with a real-world user is essential, because one of the things Jack, my co-founder who used to work at Google DeepMind, and I both observed from our work in tech and energy industries is that there's quite a big divide. So the energy industry is super busy. They're just struggling to keep the grid alive. They're all squeezed for time and money, and there's a lot of pressure, and there's a lot of risk aversity. Whereas academics have got a lot of great ideas, but they don't have the real-world data sets. So what we're trying to do in Open Climate Fix is bridge that gap. So we worked very closely with National Grid. We've developed a solar forecast which importantly uses satellite imagery. So if you can imagine satellite imagery, it gives you a pretty good idea of where the clouds are. And why is this important? Because if a large cloud comes over, say, Norfolk, it can wipe a gigawatt of generation off of the country's generation mix at short notice. And that means to avoid a blackout, as we saw in Spain recently again, we need to quickly turn other generation on. So the more we can tell National Grid when the clouds are going to come, and the more real-time information we can give them with this modeling of clouds, the better for them, and the less reserve and backup generation they have to keep running. That reserve and backup generation is all gas-fired pretty well. So that gas-fired generation is inefficient, and it's generating a lot of carbon. The AI is involved in incorporating the weather and the satellite, and we're now actually forecasting cloud movements explicitly from the satellite imagery in basically like a video prediction. Effectively, we're doing video prediction on clouds, and that allows National Grid to halve the errors they're seeing with their solar forecast. It improves the accuracy in their forecast of demand as well, because most of the solar is embedded in people's houses and in the low voltage network. And it saves them 300,000 tons of carbon per year, which with our solar targets will be equivalent to 1 million cars off the road, internal combustion engine cars off the road, once this is at our solar target. So this is quite big impact for National Grid, and at the same time it's got the chance to reduce the queues. So one of the challenges with the solar power and connecting solar farms is these really long queues, and those really long queues exist a lot because of
By queue, you mean to attach to the grid? Yeah, projects backing up, waiting for connections.
Thanks.
Yeah.
Yeah, good point, yes. Yeah.
Okay.
Not a queue of electrons.
Yeah.
Yes.
Yeah.
So this is really exciting, and the exciting thing now is we're taking that to India, so we're doing the solar forecasting in Rajasthan in India, and had a conversation on Monday with the Chinese state-owned corporation regulator and the Chinese grid. So, this is all open source, so the idea is that we're a non-profit org, I should say. So the idea is that we can take this open source code, and the Chinese could take it and we could guide them through using it. We don't have to run it for them, because we want to make sure that IP is transmitted as quickly as possible around the world.
Great, and that's a great jumping off point for us. So we've got examples here. You've mainly trained your models on the UK and moving out now to India and hopefully China and elsewhere. And Fouad, you've trained your model on California. How transferable are these technologies? How much of it is dependent on you being in the country, or can you see it scaling?
Yeah, well, our first sort of goal is to move to other states, and in that sense, they are fairly well transferable, because almost all the states in the U.S., literally all except one, have a bicameral legislature, and all the terms and technologies and processes and bill nomenclature and everything is very similar. So, right now we're facilitating a move to Hawaii, so we can do the Hawaii legislature fairly easy there. We have to have a lot of requests to do other countries and even municipalities like the city of Los Angeles, which is huge on its own. But that will be more difficult for us because all the processes and videos and things like that are not as standardized. So our goal at the moment is to cover the rest of the United States.
Right. Well, and we'll join forces ultimately. We'll bring Europe and UK into this method as well. And Dan, when you sit down with Indian grid operators, what are some of the specifics to India? My husband's Indian, and I've spent a fair amount of time there. I would imagine, actually, in some cases, you've got perhaps other factors affecting the solar installation, maybe column of air, the dust in the column of air.
Monsoon season is the hardest because monsoon atmosphere is extremely high energy because it's very high temperature and it's very high moisture content, so clouds can literally just appear out of nothing in a very short time frame. The Indian forecast is really easy the rest of the time because, as you say, it's a little bit dusty and hazy, but otherwise there's no clouds. So it's just predicting the haze.
The haze is the thing.
Yeah, absolutely. So it's a really interesting question, though. So we would retrain our models on Indian's grid in order to capture the idiosyncrasies, but you might say 80% of the IP is directly transferable. So AI does transfer very easily across the different geographies and different problems. The biggest change is not so much the atmosphere, but it's the personalities. You know, it's getting those personal relationships and getting people to buy in to this idea.
So that's a really good point. So I, obviously, as we've just discussed, there's a lot that AI can do. It's like having a superpower that adds to your kind of toolkit, but there's still a real need for humans in the loop. And I'm wondering what both of you would say to someone, maybe just starting college or even to people younger than that. Like, what are the most exciting things you need to be learning that help make sure you've got a job in the future? Because this is going to be quite a disruptive phase that we go through, right? So what would you say to a young person saying, what should they be studying?
Yeah, great question, Baroness Worthington. I feel like critical thinking is the #1 skill that you must have. Algorithmic journalism has been around for a while, and with large language models, some people are doing it, and they are producing entire stories just from the AI. That we found does not work, because it's missing the human element. So our product is an aid to journalists, but it requires a real journalist to take this information and tip, whatever it is, to use their human processes to bring in interesting other stories that may not be in our database. So that requires critical thinking. That requires understanding of the situation. That requires knowing something about the politics and the inherent trade-offs, the inherent conflicts that exist. If a person said something very interesting that the tool has surfaced for it to be newsworthy, you can take that and sort of marry it with everything else that you know as a human about that person, about the situation, and do it. So I don't think that kind of skill will ever go away. In fact, it will be even more useful, because in the future we're going to have the problem of too much AI, too much sort of bad AI. People have already done Google searches, know what I'm talking about, right? Google searches are terrible now, because maybe the first 4 or 5 hits on a Google search are AI-driven articles. And you're going to need more critical thinking skills to overcome that, to siphon through that.
And Dan, what's your advice to the younger generation?
Yes, my son's 16, so it's coming up to the age. So firstly, critical thinking, 100% agree, and I think being able to discern, pick your way through the AI deluge of data. The other thing I would bring into the picture is, so I might, at the risk of offending some people in the building, when I first started working in an electricity grid, in fact, in Australia, I quickly concluded that sales people and lawyers were a complete waste of space, and that we should just get rid of them all. After working for 20 years, I decided actually both are crucial to making things work, right? Lawyers, because you need to be precise and construct contracts, etc. But salespeople, because a good salesperson is invaluable, and I think sales should be viewed very broadly. It's about getting an idea across, communicating an idea. You will never implement a technology without any people involved, right?
Yeah.
So I think, and my co-founder Jack Kelly worked at Google DeepMind, so obviously he's very smart in the coding side, but he's also spent a few years doing filmmaking to try and convince people about the climate emergency. And I think that shows in his ability to sell and communicate the deep learning. So I think that sales and people skills is never going to go away.
I think you're absolutely right. And I'm going to open up for questions now for the last 5 minutes, but I'll end on a little recent anecdote that perhaps people in the room will appreciate if they're coming from the energy transition space. We were discussing how do we communicate the benefits of heat pumps to the public, and we were trying different methods of understanding. I mean, if people who know about heat pumps will know that there's this thing called the COP, which is the coefficient of performance, which is like tells you how efficient a heat pump is in a certain circumstance. And it's a really vital thing. It tells you if something's going to pay back and be efficient or not. But so everyone in the industry talks about COP3, COP 3.5, COP 4. I mean, it's just not easy to understand. But it's so vital because it tells you how much you're going to benefit from this thing. And so we were asking ChatGPT for variations, but it wasn't coming up with anything exciting. And then we went out for lunch and asked a friend from a different sector, and he said, oh, it's just like a buy one, get one free offer. You should just call it buy one, get three free. And the creativity it took to just understand the context switch is something in AI kind of still, I mean, there are creative AIs, don't get me wrong, but it's just that combination of human insight and being able to take one scenario and see it. And the AI struggles, right, because it's used to pattern recognition. And what sometimes you need is a complete break from the pattern that you're in. So, yeah, lots of room for humans. I'm telling my kids to try and be creative and follow their heart a little and not get too worried about code club, because entry-level coding, I think, is probably one of the first casualties. So, right, we have, I think, just 5 minutes. So if anyone does have any burning questions for anyone, please raise your hand. I think we'll probably take 2 together if there are any takers. If not, I'll fill the time. Oh, we've got a lady there. Anybody else? Great, well, we'll start with you. Thank you.
Hi. Data centers and AI obviously have a massive impact on the environment. They've got a very large carbon footprint. So are there any possible benefits to AI that could possibly outweigh this impact?
Dan, do you want to
take that one? Yeah, so yes, we're acutely aware of this, and we ask ourselves this question. We've done the calculations. So we use less than 100 tons of carbon on training all of our models over a number of years. And we are saving National Grid in the UK of the order of 300,000 tons of carbon. So, and if you add that over a few years and maybe take it to India, you're looking at a 0.01% of carbon usage versus carbon savings. So we're very comfortable with it, but I think there is an issue about, like watching lots of cat videos and generating them, and how useful is that for the planet? Probably not so useful.
One thing I want to add is that, as someone who teaches AI, I get asked a lot about AI, and then what people think about AI is basically large language models. Like, that's what people call AI. The fact is, AI has existed since Alan Turing, and it's been 50 years of different processes and algorithms and efficiencies. So not everything is large language models. Our operation happens to be very small in order to, so it's not making any kind of a serious AI impact. But we're also not driven by large language models, which is what's seen all of the growth in the last few years. So large language models are not a big part of what we do. In general, I would say that there are a lot of savings in AI simply because there is ways of doing things more efficiently. So think about the reporter who doesn't have to drive 600 miles. California is a big state. To go to Sacramento and cover the story, or think about the person who is able to receive all their information without a printed paper being on their doorstep. So there are some benefits that way. Of course, we always have to watch out for the climate footprint.
Thank you for that question. I would just add that there have been many studies that have looked at what's the cause of rise of demand, and whilst data center projections are there's still a fair degree of uncertainty. And what we do know is that currently what some of the demand globally is coming from is extreme weather. So at the moment, air conditioning use in urban centers is what's driving up global demand. And if we could just get the system of energy and air conditioning and more efficient, those are the big drivers up of demand at the moment. That's not to say that data might not take over, but it's still not there yet. And I suppose, yes, anyway, we have time for one more question, I think. Well, I will, if there's no takers. Oh, yes, sorry. Oh, now we've got 2. Do you both want to say something very short?
Hi, Peter Weston from Energy for Impact. We're doing a lot of work around grid optimization. Just interested to hear your views. What would be the the top 3 most important uses of AI to improve performance on grids.
Perfect. And the next gentleman to your... Was there someone else? Or we can just take that one. Okay. Right, let's make this rapid fire then. Top 3 uses to improve the grid.
Great.
Boad, you're going to come at this from a political perspective, I'm sure.
Great.
But yeah.
I can let Dan handle it.
Forecasting of renewables and demand, which we're doing already. Determining what's in the grid, so just actually using AI to map back and understand where the solar panels are, which bizarrely we don't know. Most countries don't know where the solar panels are. And lastly, I think optimization, which is maybe what you're doing already, trying to optimize how those electrons move around the grid in the best way.
Boad, your top 3.
I think I couldn't top that, and Dan is the expert on this one.
That's true. No, I would answer it from a political perspective, which is make sure you're tracking make sure you're a member of a group, or you're supporting a group, or you're buying a journal that is tracking what your elected representatives are saying about grid permissioning and building out of transition cables, and making sure that we don't get good at stopping things from being built but keep building. There's a big debate in the US at the moment about the abundance movement, the need to get good at building again. And if you don't elect representatives who can see the need to get building again and get this clean stuff into the ground, it's surprising how politics can slow things down. It's been slowing things down for the last few decades already, and it hasn't stopped. So if we are able to optimize grid, we're going to need to have the public behind us in building out the things we need to improve it as well. So don't forget the social and political aspects. Right, we are out of time, and I'm so grateful to you both for joining me here. Thank you too for listening. I will be back on stage at 4 o'clock for an amazing talk with Merlin Sheldrake about mycorrhizal fungi. So just a little bit different, but so I hope to see some of you back then. But I will now say thank you to our panelists. Thank you.
Thank you.